Okay, so I'm going to try to tackle this question, which was essentially one of the harder questions on the redox unit test. And so it's asking us to balance this reaction. It's an acid. Now, it should have probably said that in the question, but since obviously it's included water and hydrogen ions in the answer, we're going to assume that it's an acid. And there are, I think, two reasonable ways to try to get to the right answer here. When I do this kind of question, I like to do it using oxidation numbers. So if I've got chlorate ion, the oxygens have a -2, sorry, not 2 minus, but -2, and chlorine is +5, and beryllium, the element, has an oxidation state of 0, chlorine has an oxidation state of 0, and this ion down here has got a -2 for my 3 oxygens, and so this, and this was 2 minus, not 1 minus, so this is going to be +2 for each of the berylliums. So if you're not sure how to get the oxidation number, you need to go back and take a look at that. Here I can see that my chlorines are going from a +5 to a 0. So this is going to be OA, and my beryllium is going from 0 to +2, so this is Leo Ra. And I've got a transfer for the chlorine, which goes from +5 to 0, is going to be 5 electrons per chlorine, and that's 5 electrons per this chlorate ion. And my beryllium goes from 0 to +2, so it's 2 electrons per beryllium, and, well, it's just beryllium. So my lowest common denominator would be 10, so I'm going to multiply this by 5 and this, or this by 2 and this by 5, and that's what my coefficients would be. But I'm going to run into a problem here. I've got 2 berylliums here, and so I'm not going to actually get that balanced. And this is where I suspect some people may have run into some problems. So I'm going to instead double this. So I'm going to make this 2 of the chlorates, I'm going to double this. So instead of it being 5, I'm going to have 10 of these, and I get 5 of these. And so over here, I was going to make this 2. I'm going to instead double it to make it 4, and I'll get 2 of these. And I had to do that because I had the berylliums here were going to be bad numbers. If I'm multiplying this by 5 and this is an even number, I can't make those equal otherwise. So by doing this, I take care of my electrons. Now I've got 4 chlorines on both sides, 10 berylliums on both sides, and then I need to balance my oxygens using water. So 4 times 3 is going to be 12 oxygens on this side, and 5 times 3 is 15 oxygens on this side. So I add 3 waters to this side. And then in the reactants, I have 6 hydrogen ions, and in my products, I'm going to need to have 6 hydrogen ions. And now it is balanced. I've got a total of 4 times -1 is 4 negative on this side. Over here, I've got 5 times 2 is 10 negative, but then I have 6 positive, so I have a total of 4 negative on both sides. So the reaction is balanced that way. You could also go ClO3 minus becomes Cl2, and then you have beryllium becoming Be2O3 2 negative, and we can try to balance the 2 half reactions. So I've got 2 chlorines on both sides. This side, the reactants for that has 6 waters, so I'm going to need, or 6 oxygen, so I'm going to need 6 waters, and then I would need 12 hydrogen ions. And you can see that in the reactants, I have a total of 10 positives. So I put 10 electrons here, and now I've got equal charge. In the second reaction, I'm going to have 2 berylliums. Now the berylliums are equal, but I'm going to need 3 waters here. And if I've got the 3 waters, then I'm going to need 6 hydrogen ions here. And I've got a total of 4 positives in the products, 0 in the reactants, so I get 4 electrons here. And then I can balance my electrons. So the lowest common multiple for 10 and 4 is going to be 20, so I'm going to multiply this by 2, and this one by 5. And then if I do that, I'm going to end up with 4 chlorates plus 24 hydrogens plus 10 berylliums plus 15 waters become 2 chlorines plus 12 waters plus 5 beryllium, whatever this thing's called, plus 30 hydrogens, and that'll, 30 hydrogens, so hydrogen ions, that's 30. And now I'm going to need to cancel out. So if I've got 24 hydrogens here and 30 here, that's 6 hydrogens. And if I've got 15 waters, and on the other side I've got 12 waters, that's going to leave me with 3 waters here. And I got 4 chlorines. I end up with the same balanced reaction. So it's a 2 different strategies to be able to get to the same answer. It is a trickier question.